Welcome to Eureka Math. I'm Mr. Shankel. I'm going to be helping you today with Module 4, Lesson 26. Let's get started. All right, we're going to sketch the graphs of the system. So we have two linear equations, both in slope-intercept form. So I'm going to use that to my advantage. I know that the first line is going to cross the y-axis at positive 4, and that the slope is up 2, right 3. So here's my 2 points, and then I can draw a line that represents that linear equation. And then for the second one, I see this second line crosses at y equals negative 3. The slope is at negative 3, so it crosses the y-axis at negative 3. That's here. And the slope is up 4, right 6. Up 1, 2, 3, 4, right 1, 2, 3, 4, 5, 6. That point is right there, and we get this line. All right, so there are our two lines, and what I'm noticing here is that they look parallel. They look like the exact same slope. So what I'm going to check is the slope, 2/3 and 4/6. Well, if I simplify 4/6, I get 2/3. So my slopes are exactly the same. And if my slopes are exactly the same, but I have a different y-intercept, that means I have parallel lines. So this different y-intercept with the same slope tells me I have parallel lines, and there are no points that will satisfy both equations because they never cross. There's no intersection. Okay, here we go with number 2. Let's check this one out. Right away, I see they both have the same slope, but they have a different y-intercept. So we'll graph them. We'll see where they're at. But if I cross at 7, that's here, and then the slope is down 5, right 4. Down 5, 1, 2, 3, 4, 5. Right 4 is here. So there's one line. Okay, that kind of goes right through there. And then my other line crosses at a positive 2 with the same slope. That means I'm going to go down 5, 1, 2, 3, 4, 5, and right 4. That point is here. And if I run my line through those 2 points, I get that one, and they are parallel. So I have parallel lines again, and I know that they're parallel because they have the exact same slope. And if they have the exact slope and their y-intercepts are different, these are parallel lines. They will never intersect, which means there's no solution for this system. Okay, let's check another one. Y equals 2x minus 5, y equals 2x minus 1. I don't even have to graph it, right? I can look at it and say, well, they have the same slope, 2. And they have a different y-intercept. One's negative 5, one's negative 1. These are parallel lines. They're never going to cross. There's no solution. That's what you'll be able to do once you've done a bunch of these. You can see that, but let's just check it. If I cross at negative 5, that's my point. That's my y-intercept. And then my slope is up 2, right 1. Okay, so then my line's going to go through those 2 points. So it's going to look like that. And then if I cross at negative 1, that's my y-intercept, and then up 2, right 1. And then if I run my line through those 2 points, I get parallel lines. Parallel lines, they're never going to cross. There is no intersection, so there's no one ordered pair that will satisfy both of those equations. And that means there's no solution. All right, let's jump to number 7. Does the system of linear equations shown below have a solution? Well, it's in standard form, so I'm not really sure right now, but if I change it to slope-intercept form, I can tell you. So let's do that. 6x minus 2y equals 5. Let's change that to slope-intercept form. Subtract 6x. And we get a negative 2y is equal to negative 6x plus 5. If we then multiply by the reciprocal of negative 2, that's negative 1/2, and do that to both sides, then we will get slope-intercept form. So a negative times a negative is a positive. The 2's cancel. Y equals, and we have a negative 1/2 times 6. That's a positive 3x. And then a negative 1/2 times 5 is a negative 5/2. So there we go. That's our slope-intercept form. And now all I'm going to do is do the same thing for my other equation and check this slope. If the slopes are the same, I know they're parallel lines. All right, so 4x minus 3. Let's see. 4x minus 3, y equals 5. Subtract 4x from both sides. We get a negative 3y is equal to a negative 4x plus 5. And then we can multiply by the reciprocal of negative 3. That's a negative 1/3. And do that to both sides. Multiply by a negative 1/3. And we get y is equal to, well, a negative 1/3 times a negative 4 is a negative 4/3. So that is a positive 4/3 x. And then we have 5 times negative 1/3. That's a negative 5/3. So there are my two equations. Does the system have a solution? And the answer is yes. They are going to intersect because they have different slopes. So I know they will have a solution because they have different slopes. And that means they're going to cross each other. And wherever they cross each other, that is my one point that will make both equations true. All right, let's check number 8. Let's put these in slope-intercept form. Negative 2x plus 8y equals 14. I'm going to add 2x to both sides. That gives me 8y equals 2x plus 14. And then we're going to multiply by the reciprocal of 8. That's 1/8. Multiply by 1/8. And when we do that, we get y equals 1/8 times 2. That's 2/8, which is 1/4, if I simplify, x. And then that's this. And then 1/8 times 14, that's 14/8, which would be 7/4 simplified. So there's the equation for the slope-intercept form of the equation for the first one. And then for my second one, I have x equals 4y plus 1. I want the y all by itself, so I can do that from here. I can just subtract 1. I get x minus 1 is equal to 4y, and then multiply by the reciprocal. And let's see, we get y equals 1/4 times x is 1/4 x, and 1/4 times negative 1 is a negative 1/4. So there's my slope-intercept form, and I can see that my slopes are the same. So here are my slopes, the coefficient of x, 1/4 and 1/4. Slopes are the same, so they're definitely parallel, and I just need to see if they're the same line, and since this one crosses at 7/4, almost 2, and this one crosses at a negative 1/4, I know they're different lines. They're just parallel, and they're never going to intersect. So no, this system of linear equations does not have a solution. Okay, next one. Same thing. We're going to change this to slope-intercept form. 12x plus 3y equals negative 2. Subtract 12x from both sides. And we get 3y is equal to negative 12x minus 2. And then we'll multiply by reciprocal. And when we do that, we get y equals, and then we're multiplying here, negative 12 divided by 3 is a negative 4x. And that's this. And then negative 2 times 1/3 is a negative 2/3. So there's the slope-intercept form of the first equation. For the second equation, (4x plus y equals 7). Subtract 4x from both sides, and we get y equals negative 4x plus 7. So there is the slope-intercept form of the second equation, and right away I noticed that I have the same slope, negative 4. So it's either the same line or parallel lines, and since they cross at different points, these are parallel lines, which means no solution for this system. Okay, last one. Jenny babysits for two different families. One family pays her $6 each hour and a bonus of $20 at the end of the night. The other family pays her $3 every half hour and a bonus of $25 at the end of the night. Write and solve the system of equations that represents the situation. Okay, so let's write the two equations first. The first family is paying $6 every hour. That's I'm going to say that the amount of money that she makes, y, is equal to $6 times the number of hours that she works plus the $20 that she gets at the end of the night. So that's the first equation. And then the second family, well, the second family is paying $3 every half hour. That's also $6 an hour. Y equals 6x plus the $25 bonus at the end of the night. And I can see that the slopes are exactly the same, meaning parallel lines, as long as the y-intercepts are different, and they are. So these are parallel lines, and they will not pay the same for the babysitting services. So no solution for that system. That's lesson 26. I hope that helps. See you next time.